now we come down to how the data center networking is organized. So initially what happened was that most of the companies, what they did was they had campus switches that connected to the campus distribution area, and then campus core, and the servers were hanging out of that, and then they had the edge routers which went to the telephone company, to the carriers. That slowly became standardized as follows, is that basically they have servers. On the servers they have switches which we call access switches. Alright, servers are connected to access switches. Access switches are connected to aggregation switches. Aggregation switches are connected to core switches. Alright, and so there are now 3 tiers of hierarchy. You go to access, aggregation, and core. And so all the servers are here at the bottom, not in the middle anywhere. And then from core you go to the outside. So the important thing to notice is that there are 3 tiers, and their names are access, aggregation, and core. There are 20 to 40 servers per rack. I suppose everybody has seen a rack. Anyways, there are 20 to 40 servers per rack. Each server is connected to 2 switches. So that is an interesting thing to notice, that everything is dual connected. You see, this server is connected to both access switches. Right? And this switch is connected to 2 switches. And this switch is connected to 2 switches. Everything has a redundant connection. You understand why?
For redundancy?
Yeah, reliability. Right? If something fails, the other one continues. So each 2 access switches. Right now, 1 gigabit is common, but 10 gigabit is coming in. So if you buy a new thing, you buy 10 gigabit. If it is the old thing, 1 gigabit. For example, at your home, my home, in every lab, 1 gigabit is common today. I mean, you don't buy anything less than 1 gigabit. Right? But if you're a company, then you spend 10 gigabit. Access switches connected to aggregation switches. Aggregation switches connected to access routers. Now you see the word routers and switches. What is the difference? Layer 2 and layer 3. Yeah, good. So these are layer 2 devices. These are layer 3 devices. These speak Ethernet. These speak IP. Access router connect to the core routers. Actually, this is wrong. So let's see. Aggregation routers connect to the core routers. Access connect to aggregation. These lights are hot off the press. Right? So there are some bugs in there. Basically, if you can correct in your slide, you can see access connect to aggregation. Aggregation connects to the core. And then this one can go away. Okay, basically that's it. There's nothing else. It's not. There's no cycle backwards and forwards. Access doesn't connect to core. Aggregation connects to the core. Then aggregation layer is the transition point between L2 and L3. And nowadays there is a requirement for low latency, because if you are running a stock market brokerage firm, a few nanoseconds and microseconds can make $1 million difference. Right, so you don't want your messages or your sales order to be stuck in an Ethernet queue. Yeah, the core router is connected to the edge routers. Edge routers are connected to the core routers. Core is connected to aggregation. Aggregation is connected to access. Right? Yeah. So the first thing should be edge, maybe. So edge routers connect to the core routers. Here, he says edge. Yeah. So edge routers. I think that will fix all the errors. Alright, by the way, all the information has a reference. So I'm kind of putting every reference that that information I have taken from. So here is a paper from SIGCOMM. Actually, SIGCOMM paper became CSEM paper. So this is where it came from. Core routers manage traffic between access routers in and out of the data centers. Okay, I think that I know what is the problem. I know the problem is. No. The problem is different people use different terminology. So Greenberg is using terminology here which is not the same as used by the rest of the industry maybe. And so this picture came from Cisco. Okay? And this description came from Microsoft. And I didn't realize that there is some difference in the terminology. But right now, let's just try to see. We just try to follow the figure as our main guide, because I think that figure is more authoritative. The thing is, there is no new information here. The main thing is that everything is dual connected, period, and most of the traffic is internal. That is the key point, is that originally when the data centers were designed, or before they were designed, the traffic was going north-south. Right? Now, today, they don't go north-south, they go east-west. Why? Because these servers are talking to each other more than they are talking outside. And that is a key change in the traffic pattern. And so that is the important point to notice. Most traffic is internal to the data center, and the network is the bottleneck. Some of the links have utilization of 80%, and most of the flows are small, and so on and so forth. So basically, the Microsoft guys did some measurements that most of the flows are, mode is 100 megabyte. Yeah, mode is the most common entry. So if you look at the graph, wherever the peak is, that is the mode, right, is 100 megabyte. And DFS is the distributed file system, which is the commonly used file system, uses 100 megabyte chunks, and that is why there is a mode there. Because if in DFS, if you're using DFS and you say, okay, I need this file will be broken into 100 megabyte chunks, and you will be sent one chunk at a time. So your each flow would be 100 megabyte. And then there will be a gap, then there is another flow, and then there is a gap, there is another flow. The thing about the data center equipment, and we had talked about 3 tiers here: the access tier, the aggregation tier, and the core tier. The access is all layer 2. The aggregation is half layer 2 and half layer 3. Core is all layer 3. Right? You see these symbols here, these, okay, now. The thing about, so Cisco calls them switches all the way through. Even layer 3 is a layer 3 switch. And there are layer 4, layer 5 switches, right? And Microsoft had called some of them as routers and things like that. There was confusion about all that, right? And so basically now I'm just following the consistent terminology, calling all of them switches, and calling by the name access, aggregation, and the core, like in this order. So each access switch connects to aggregation switches connect to the core routers. If you want to call them core routers, connect to the edge routers. So the edge routers are outside. These are the edge routers. They connect to the internet, and the core routers are inside this domain, right? And then aggregation layer is the transition point between L2 and L3. So this is the aggregation layer, is the transition point between L2 and L3. And low latency, high frequency trading markets, so that we talked about, that has, basically as before, the latency is important. Core routers manage the traffic between the aggregation, okay, I missed here, aggregation switches in and out of the data center, okay. So basically that is as before, the core routers manage the traffic between the aggregation switches. If this and all the switches below the aggregation switches form a layer 2 domain, because there is no layer 3 here. This whole thing is one layer 2 domain. Okay, as long as you don't go to the router, everything has one broadcast domain. And it consists of several hundred servers. Most traffic is internal, and the network is the bottleneck, etc. remains as before. All right. So now, where do you put the switches? The first switches that we call access switches. You can put them on the top of the rack, or you can put them at the end of the rack, end of the row. If you put them on the top of the rack, then you have a shorter cable to the servers. And if you put them at the end of the row, then you have one place where you can change from 1 gigabit to 100 gigabit to 10 gigabit. You can keep changing the networking and don't have to touch any racks. So they both have their advantages and disadvantages. Which one you have to change more often? The cabling or the switches? Right? And so end of the rack puts all the networking equipment in one rack, and top of the rack is puts shorter cabling. And so we already said all of this is that the difference between these two is easier cabling. The rack is not fully populated. The problem is that if the rack is not fully populated, then you have unused Tor ports. So here's the thing. Suppose you have this is a 24 port switch and only you have 4 servers, then 20 ports are not being used. In this case, you don't do that. Why? Because you can connect any server to this switch. Right? So you have less networking equipment, less networking investment. Alright, if the rack is not fully populated, there are unused Tor ports, which is basically money gone down the drain. If rack traffic is high, difficult to add more ports. And for some reason, suppose you need more than 24 gigabit, then you cannot put 25th. With the other one you can put. With the end of the rack, you can put one more switch and connect to that one. There is a scalability. Upgrading the speed is same thing. You can easily upgrade the networking equipment with the other one. The main negative of the ER is longer cables. Now you have to manage the cables. Equipment is good, but the cables are long. Servers can be placed in any rack. That's another positive. Server can be placed in any rack. Ports can be easily added, upgraded, and so on and so forth. So that's very good, right? So you have to decide which one is cheaper or better for you. Now, the thing is that you just don't need the servers and the switches. You need a lot more. What you need is lots of what we call application delivery controllers or application delivery services. For security, you need VPN servers, you need IDS, intrusion detection systems, you need firewall. For performance, you need load balancers. For networking, you need DNS. What is DNS? Domain name system. DHCP. What is that? Dynamic host control protocol. Somebody is saying very slowly, but other people are not even saying. NTP. Network time protocol. FTP. File transfer. Everybody knows that one. Radius. Yeah, okay. You got the first 2 words right. No. Remote access. Basically, and I can't remember myself the whole thing, but basically this is the server that you use for your remote authentication. Okay? For remote authentication. So when you sign in, for example, here in WashU, the authentication would be some other place, central place, and that is the Radius server. Database services, SQL. So all of these things which are shared by all the servers, the best place to put them is between access and aggregation. This is the place. ADCs are application delivery controllers. They are located between the aggregation and the core. ADCs are located between the aggregation and the core routers. So application delivery, he's saying, is that really this layer is for east-west traffic. So if you want to go from here to there, you would go through this, from this access switch to the aggregation switch and come down. Right? And so it may not require you to go through this one. Firewall, etc. are layer 3 and higher services. They are not Ethernet services. Right? Ethernet devices cannot look at IP packets or IP headers, things like that. So we need to really put it where the layer 3 is, and layer 3 is really here in the core, between the core and the aggregation. So all these services belong there, not here. Already got it? All right. Oh, there is one more sentence here. Stateful devices on the aggregation layer. And so what is stateful? Stateful means state of the TCP connection. Now this is a little bit complicated. Let me explain. Is that many devices are stateful, many devices are stateless. For example, when you do DNS, you ask for the name, and then if you go back to ask the name again, it doesn't remember that you asked for the name already. DNS is totally stateless. In fact, routers are totally stateless. If you send a packet to Germany, it will look up in the routing table and send it to Germany, and then you send the next packet to Germany, it will look up the router again, and the router will look up it doesn't remember that the previous packet I just sent was to Germany. Alright? So they are all stateless. After one packet is gone, they don't remember what they did. Second packet, they have to start from the beginning. Those are totally stateless. But firewall remembers that you set up a connection, that the connection is not still acknowledged, that you asked for this object and now you're going to ask for this object and things like that. That is totally stateful. It remembers what you have done so far and what you should be doing next and not what you should not be doing next. It knows everything. Alright? So those are stateful services. Stateful services such as firewalls have to go on the aggregation layer, which is actually, I think, we kind of agreed that most of these things have to go here, above the aggregation layer and not below. We had a problem with this slide. And the problem was, where do you put the appliances? So all these in the data center, you not only have servers and switches, you also have other appliances such as VPN, server, intrusion detection, firewall, load balancers, DNS, DHCP server, NTP server, FTP server, Radius server, and so on and so forth. So all of these go between the aggregation and the core router, and this picture shows it correctly. Alright, aggregation and the core router. And so this is the access, this is the aggregation, and this is the core. In between those, there is these are the devices that actually Cisco sells. This picture came from Cisco, so it has Cisco's model number, but other companies work equally well. The another thing I have done this time, and I will be doing it from now on, is that all the acronyms that are here, they are defined at the end. So for example, Radius, we could not remember last time what Radius was, and the Radius is remote authentication for dial-in users. Okay, server. So basically, Radius came from dial-in days when you were dialing into a website or into what they used to call them. You logged into for internet access, and so basically Radius server were used, and they still continue to be used. So even when you do right now, Radius is used. So all of these acronyms are defined. Now there is one more detail as to how do you connect these switches. So you see, the normal method that we have is that you connect the top of the rack or the end of the rack, doesn't matter where they are, a server to two switches, and two switches to two switches, and two switches then going on to the higher layers, right? So the aggregation switches actually have two layers, layer 2 and layer 3. Everything that has layer 3 has layer 2, by the way, right? So these are the layer 3 devices, these are layer 2 devices, but you can connect at the layer 2 or you can connect at layer 3. So this would be an IP link, this would be an Ethernet link. And so if you connect, this is a common method, let's say connect, which is called looped triangle. So there is a triangle here, and there is a triangle here, and then there is this loop. So this is a looped triangle. If you connect like this, what is going to happen is that a spanning tree is going to be run between these switches, Ethernet switches. And the spanning tree will say there is a loop here, and you don't want to have a loop, because if there is a loop, then the traffic will just circulate. So it will say, please disable these two links. So these two links are there, but they are blocked by the spanning tree. And so the real topology is you can go from here to there, but not there. This is blocked. From here you can go there, but not here. You can go from here to there, but not here, right? So this switch is actually not being used at all. So only this switch is working from both the switches. Both the switches are going to go to the same switch. So now you are not really using 50% of your equipment. I mean, not 50%. At least you are not using one of the two switches here, and you are using these two switches, but you are not using this switch. So that is the problem. So you don't like that. Well, I paid for a 10 gigabit port and it cost me $1,000, but I'm not using it. Spanning tree simply says don't use it. So the next option is to connect like this, looped square. Now these four switches will run a spanning tree, and the spanning tree will say that please block this link because there is a loop. Now once you block that, then there is no loop. And the problem with this is that oversubscription doubles its failure. Now, what is oversubscription? Oversubscription is that you have more traffic coming in than going out. Actually, oversubscription comes from the airline industry, where they book more seats than they have seats on the plane. You know that? Right? Every airline books more seats than they have seats on the plane. That's why when you go to the airport, they say, well, we are overbooked. If anybody wants to, do this, we'll give you so much money. So what do you do on the Ethernet? We do the same thing on the Ethernet. We put maybe 40 1 gigabit links coming in, and then we generally have only one 10 gigabit link going out. How much oversubscription we have? 4 times. We have 40 gigabit coming in and 10 gigabit going out. So the oversubscription is 4 to 1. We hope that not all 40 will be sending 1 gigabit at the same time. So that is called oversubscription. Now, so all the links are oversubscribed. Right now you are using this way and this way. 1 gigabit here and 1 gigabit here, right? Because you are using both the ports. You can send 2 gigabit. But if this link breaks, then both 2 gigabit will go here. Now you are oversubscribed by a factor of 2. So that is negative of that one. Positive is that you are using both the links. Then you go to the third one, which is loop free U. Loop free U, and here the link is at the third layer. There is no link at the layer 2. So Ethernet, when they run these switches, when they run spanning tree does not find a loop. Doesn't block anything. So the problem is there is no L2 communication between the aggregation switches. If any link fails, if any of these links fail, this switch cannot talk to this switch at layer 2. It can talk at layer 3, but not at layer 2. It cannot tell the neighbors, look, my link is broken, let's reconnect or do something. Right? So your layer 2 communication is broken whenever any link breaks. The last one is loop free inverted U. And so this one basically has a link at the layer 2, and these 4 switches, when they run the spanning tree, then nothing is blocked, so that's good. But the problem with this one is that black holes on some failures. If something failed, then the traffic just goes into the dustbin. Okay? So let's see what will happen. Let's say this thing failed here, or this link failed, and the traffic goes to this switch and it cannot get out anywhere. So anyway, there are 4 possibilities, and you can see that each one has a negative and a positive. By the way, all of this information came from this book. So somewhere earlier I have given the complete reference to the book. You can read that book. The book is very good. This is one of the recommended books that I have put among the 3 books. See, whenever a spanning tree discovers a loop here or over there, triangle or square, it breaks a link. Clear advantage. So what I have done is I have tried to put the clear disadvantage on everything, right? So there is a clear disadvantage of this is black hole. And so when we talk about a spanning tree, which we will at some point, then we'll see why we need to get rid of a spanning tree, just like this reason.